trillion nanogram per liter, very low level. Even at that level, these are the problems. High cholesterol, thyroid disease, kidney cancer, testicular cancer. Cancer events, increased risk of like prostate, kidney, testicular cancers. This is by the EPA, by the way. I'm not saying it. EPA is telling us now, in probably 2022 to between 2022 to 2024. Weight effects like increased cholesterol level, obesity, decreased immune system, developmental effects, and then your reproductive effects. So this is the health effects we are talking about. Okay, so it's not like sodium chloride or little bit of fluoride in drinking water. Okay, we are very familiar with even hard water. Okay? Traditionally, in mining areas, those are kind of secondary standards. All of this like iron, manganese, little bit of we can tolerate it. But here we are looking at scale, nanogram per liter, and look at the health effect. So amidst this backdrop, California conducted its own study. So the Office of Environmental Health Hazard Assessment, they came up with this proposition 65, and they said it's a carcinogen. These PFAS compounds can cause carcinogenicity and developmental toxicity. 2017, by the way, about California always leads the way. Among all the 50 states, California comes with the regulation first, then the rest of the 50 states they copy. So don't be surprised that I'm talking too much about California because everything happens there, and the rest of the state they follow the suit. So December 2021, PFAS and its salts precursor as carcinogen. And nobody bothered. We have all the knowledge, we understand that there are issues, there are tremendous human health concerns, yet nobody did anything at all. So these compounds were used since 30s, manufacturing, commercial production, environmental detection you can see since 2000, just last 20 years. And that too basically restricted to few chosen universities and research laboratories. Not like everybody is doing research, Until 2000, even the method detection was not even evolved. I can show you method detection recently revised in 2020. So it's not that everybody's cup of tea, that everybody can jump on the bandwagon and start doing the research on PFAS. So that was another issue. So then what, because there are no regulations, nobody is telling us what to do, So that every state in the US, they came up with their own numbers. They started monitoring their water bodies and they said, okay, this is how we are going to do it. So you can see that there are different states, have different standards. I'm not sure whether you can read it, but those dots represents the state. And this is a year, that is per PFOA, per fluoroalkyl acid. So you can see that as we move along, the advisory level, health advisory level, not enforceable, okay, not enforceable, it's just a health advisory level, like exceedance of those levels is going to cause adverse health impact. And you can see the evolution. These are for two different compounds, that is sulfonate and this is occurrence acid. So you can see this. So everybody came up with their own number, and those are all probably about 7 or 10. And then this is what I was saying, this is last year I think, I'm sorry, I was saying March 2024, but it is March 2023. This is when the federal government says, let there be a drinking water standard, just like your BIS. Could you please tell me if BIS has adopted any standard for PFAS? Anybody? Anything? No. Typically, I think in India, they reference to the World Health Organization standard, so I'm not sure whether they are using the WHO standard. I'm not sure, but this is where we are right now. So you can see that maximum contaminant level goals. Goals are aspiration, like goals are kind of cardinal rules that are written in the religious scriptures, like thou shalt not lie, thou shalt not steal. Those are the goals we strive to achieve, okay? Those are, realistic goals you can achieve, but the human nature. So, but those are the goals. And the MCL is maximum contaminant level. There's a very fine line how we define that. So if you ask me, okay, if the concentration of PFAS is less than 4 parts per trillion, does that mean I'm safe? That's not the definition. When you read it, it feels like that, but that's not the definition. The actual definition of MCL is at that concentration, below that concentration level, we do not have sufficient evidence to tell you whether it is going to pose an adverse health risk or not. But if you ask me at 5 ppt, yes, there is a likelihood of adverse risk. It is not telling you that, well, it's okay to drink 3 ppt. Okay, it does not say that. But at the same time, 3 ppt is not a violation as well. 3 ppt is not a violation of national primary drinking water standards. These are enforceable standards. It means you will go to jail, period. Is that strict? You cannot serve the water that exceeds any of this. Now you can see that they came up with these compounds. Only 2 have traditional MCL, and then there are 4 of those ones, they are 10 ppt. And then they came up with the other things also. So, this is California. Before all this happened, California has its own way, 5.19 nanogram per liter, 2021, and 6.5 nanogram per liter. They're pretty close. This is, trust me, detection at 4 ppt is a challenge in itself. Okay, don't just discover, okay, 4 ppt is okay, doable. But there are a lot of analytical detection challenges. It's at that kind of level. Nanogram per liter is very challenging. So these are the different drinking water, like in different parts of California, they have promulgated their own standard. But initially in 2021, their proposed numbers are not very far off. Regulatory measures, California Environmental Public Health Goals, 0.997 ppt for people and 1 ppt for PFAS, public health goals. This is, again, California, I was saying, from January 1st, 2025, it prohibits a person from manufacturing, distributing, selling, and offering any product that contains PFAS. Manufacturing, selling, delivering, holding any cosmetic product, we are banning. Those are not going to be sold in California. Now, this is all is happening in California only. In fact, any electronics product comes to California, it clearly says that the stuff containing this product is likely to be a carcinogen. So, the state of California sued all of these companies, 3M, DuPont, and whoever ever made PFAS, and they won all that lawsuit, close to $10 billion. So, you can see that California sued more than 100 PFAS. Now, I'm talking about this one because I was part of one of that study. I received a grant from California Department of Justice, and that's how I know and I was part of this process back then. So. Alright, so what this study, what we are talking here, we are talking about 3 distinct areas in California. We are talking about Orange County, and then San Francisco Bay Area, and the whole state of California. So, why Orange County? I live there, my university is in Orange County. So it's just very close to home. We have a lot of water bodies. We would like to know where our water comes from, what it has in it, are we being harmed? Okay? Because being there is part of, like we would like to see what kind of water we are getting. The best part, every year, all water utilities, they send us an annual report. Like, what is the water you have been drinking for all year? What are the violations, if there are any. So all of those documents we get to see. But we have never seen about the PFAS, so we ventured on doing these things. Where did we get our data? So the water board, this is a state water resource control board. They collect the data from across all the water utilities throughout the state of California. The data rigorously goes through the quality assurance and quality control protocol. It is being submitted to the GeoTracker website. And then we have enforcement and compliance history online, that is by EPA. Uncontaminated monitoring group, that's again US Environmental Protection Agency. And then RMP, Regional Monitoring Plan. So these are kind of separate, scattered branches. They conduct their own studies. For example, you can conduct your own studies for Nagpur as a whole region. That's called kind of regional in scope. So these data sets documents all of the contaminated sites and the likelihood of adverse effect on water quality and potential human health. They don't go that far. They just dump the data there, make sure that the data is robust, gone through the QA/QC protocol, and so it is available in public domain. And then we collect all those data, we sanitize the data, especially for like contaminated PFAS that are referred as detect, non-detect, zeros. We have even collected the data which is flagged as non-detect, but their method detection limit is way above the regulatory threshold, like 4 ppd. Anything that is above 4 ppd but flagged as non-detect, we still carry it for our calculations, because 4 ppd, if it's a 10 ppd method detection limit, it is still flagged as non-detect. So it's not really relevant. And then for multiple readings, if we have the multiple reading from the same geolocations, especially for those places with the same latitude, same longitude, same global ID, we have calculated the major subcentral tendencies to see what's the concentration is there. So now you have to understand that PFOA and PFAS, these are the two known carcinogens. And like all carcinogen, we do the risk assessment and we establish the carcinogenic risk. Basically, risk is chronic daily intake through different exposure routes and pathways and by their slope factor. And that's how you get your risk, which is cumulative, just a pure number. Okay. And traditional threshold is 1 in a million. The risk exceeds 1 in a million, there is indeed a risk for adverse health effect. We are not talking about those known carcinogens. What we are doing here, we are looking at the hazard index, sort of non-carcinogenic risk for individual as well as for a mixture of compounds. So there are those 4 mixtures, PFNA, HF4, DA, and PFBS. For these one, we calculate the hazard index, and just like risk, that 1 in a million is a risk threshold, here non-carcinogenic risk is essentially 1. If it is less than 1, it does not pose adverse effect. But then again, it's cumulative. Okay, if there are multiple PFAS, especially here, these are the chosen ones. If there are multiple PFAS, then cumulative risk, if it increases, if it exceeds 1, then still there is a possibility of adverse human health risk. So these are some of the studies on San Francisco Bay Area. This is the work done by a graduate student. She's actually an environmental scientist with the San Francisco Water Board. So this is her work, part of her work. In San Francisco, the situation is much more challenging to figure it out, like where the PFAS is coming from because of blending water. They use part of groundwater, then part of surface water. So once it is blended, it just changes the whole scenario. Then again, treating groundwater for potable use is a challenge because groundwater specifically is contaminated, and the levels of PFAS contamination varies according to the aquifer, the level of aquifer. So those are some of the challenges when we are looking into the groundwater. So San Francisco Bay Area, 620 miles square. 6.9 million people. So 20% of water in San Francisco comes from groundwater. It is 9 counties, sort of talukas, 7 million people, 35 groundwater basins or sub-basins. And some of these sources, commercial establishment, landfills, cleanup sites, airports. So, the San Francisco Bay Area Regional Monitoring Plan reported that PFAS were detected at 22 sites. And these are some of the PFAS compound detected. These are some of the concentration levels. You can see that, always keep in mind, 10 microgram per liter is a threshold for other PFAS, other 4 PFAS, and 4 nanogram per liter is for PFOA and PFAS. So you can see the mean concentration and look at the levels. And those are the water utilities that are drinking that kind of water, knowing that these compounds causes series of human health problems such as cancers, thyroid, weight gain, developmental toxicity, so on and so forth. These are some of the additional analysis. Zone 7 water agencies, City of Pleasanton, San Jose Water Company, Santa Clara. Who provides the drinking water in Nagpur? Municipal corporation? Okay, so do they do any of these studies? So it is done like we have the cities like small talukas, they operate their own water treatment plant. So for the entire Nagpur city, the municipal corporation, only one. And nobody done anything.
Actually now it is being run by BOE.
Huh?
The corporation is doing it, but it has been outsourced to BOE.
Okay, it has been outsourced. Okay. That's what I mean. This exercise is huge, given the population, given the people it serves. It's a huge undertaking. So I will not be surprised if the Nagpur municipality decided to outsource it. Here is one more aspect I would like to share it with you. It is a common knowledge that poor people and economically marginalized communities, they often bear the largest burden of environmental pollution. They live in the areas that is more polluted, they live next to the hugely congested traffic area, next to the railway station, bus station, so on and so forth. So there is this concept like environmental justice that try to minimize that inequity, structural disparities between folks living in the Beverly Hills and the regular folks who live in the regular neighborhoods. So this is a beautiful concept. The reason why I'm saying it, when we did this study in Orange County, and we realized, okay, where are these places where we can see the exceedance of hazard index, where we can see that there is a potential adverse health impact. Then we said, okay, who are these people? Who are these people that are living in that neighborhood? What is their income? And then it became abundantly clear that essentially folks who are economically marginalized, economically not very better off. Those are the people who are essentially exposed to this compound. So in Orange County, we collected 14,308 geolocations for drinking water samples. Again, we sanitize the data for detection. You have to use your own judgment, looking at the regulatory threshold or advisory levels. And once the data is sanitized, we calculate the hazard index for all of those geolocations. Okay, like across the entire. Initially, we started out for the entire state. We said, okay, let's prepare the map where we can see the most vulnerable population, where people are likely to get exposed to high levels of PFAS through drinking water. That was a huge undertaking. Then we said, okay, let's focus on Orange County for the time being. And so even for Orange County, we essentially gone through 14,308 geolocations. And so we calculated the hazard index, and using ArcGIS, we plotted those exceedances on a map. And then we looked into the population density and also the income levels in that particular area. Who are these people? That particular water source that has exceedance of hazard index greater than 1. So this is you can see that this is the bottom. This southern part is essentially the incorporated areas. So this map shows the hazard index and the population density. I'm not sure whether this is clear image or not, but the big dots essentially tells you that those are the places in Orange County where you can see the hazard index is greater than 1. This is a zoomed out one with again income and population. So I think this is probably the population. This is the unincorporated areas of Southern California. So we were able to pinpoint. So the whole idea of showing these slides is where are the incidences, where there is a likelihood of adverse human health impact, who are the people, what is their demographics, like what is their income level, and the population density. And then, because this is federally mandated program, environmental justice is a federally mandated program that strive to minimize the structural inequities in the environmental exposure. So this is again going back to the map. This is the United States map cluttered with all PFAS. This is typically California. Again, 21,400 facilities investigated by the US EPA. 12,000 facilities are located in California. So this is the picture, various sites in California. You can see that drinking water, military base, groundwater, municipal drinking water. So these are the different levels of PFAS. So 2 million customers, 3% of their sources show PFAS contamination, according to the Cal Waters. And these are the geolocations and hazard indices for entire state. I have shown you for Orange County. So if you happen to visit California, you should stay in the northern part of California. The water is relatively good. In Southern California, it's very expensive. Besides water, you will get the good contaminated PFAS. This is San Francisco Bay Area. Again, 1,200 sites, 18,000 square kilometer areas. So we understand that it is everywhere. These PFAS compounds are persistent. They are everywhere. They do not degrade. They stay in your bone and marrow and blood, and there is nothing you can do, okay, except for minimizing the exposure by not drinking the water. this is only just one part, okay? If you are using waterproof clothing, you got PFAS. If you are cooking with non-stick cookware, you got PFAS. If you are using cosmetics, you got PFAS. This is just a one source. And I would say, but it may not be a major source. Textile is one of the major source of exposure of PFAS. All of your shirts and pants that says no iron needed, waterproof, stain-proof, stain resistant, all of those are PFAS. So, if your water is contaminated, these are the known technologies that have shown some promising features that you can remove PFAS from drinking water using granulated activated carbon, which is a really traditional, not really high-end technology. And we are all also familiar with reverse osmosis, ion exchange. All of this, like granulated activated carbon, is essentially phase separation technology. You are not essentially removing it, but you are creating a concentrated stream of PFAS, which requires management down the line. So, but at this, for the time being, at least you can have clean drinking water. And other treatment technologies like sorption technologies, best for long-chain PFAS, sorption with brazing, reverse osmosis. In conclusion, I would say it is everywhere. Now, sometimes it feels good that ये तो हमारा problem है ही नहीं, ये उनका problem है, ये United States का problem है. I mean that's a very convenient thinking. Like it is not here, it is there. It is their problem. And it's a kind of sad thing not to know. Sometimes it's a good thing. You now get to know and then panic all of a sudden, oh my God, this is what is happening with us, and then now we cannot do anything about it. But it's a huge undertaking. So sometimes it feels like not knowing the problem, it is a good thing also. So yeah, the PFAS we are dealing here right now, these are not of recent origin, it's ancient origin. Okay, it's a legacy PFAS, just like our good old friend DDT. Okay, that's the one we are dealing with here. Because obviously a lot of things are kind of evolving. Most PFAS technologies, there are very high-end technologies, destruction of PFAS, defluorination, you can Google search it. You will find really high-end technologies, photodegradation, UV lamp, composite material, nanocomposites, destroy. But a lot of these studies, they are very promising, but they are not even pilot scale. They are remain restricted to very controlled laboratory study. When you start scaling up, only then it starts falling apart. You can publish a research paper, defluorination, you can remove all the PFAS in one go. But here we are looking at millions of people. You cannot, if you are retrofitting your existing drinking water system, it should be able to handle that. Vulnerability assessment. Again, these compounds, if it is in the groundwater, they fluctuate. Okay. If it's a rainwater, it is also, you will get additional sources of PFAS coming. You do not know. And given the nature that they are stable in the environment, there is nothing you can do. So that variability aspect is also kind of another unknown factor that challenges. In California, in around Fullerton University area, I have seen that they have put up the carbon absorption bed, and we are doing that. As the science stands, as of today I am speaking with you, in our neighborhood, Yopalinda, Fullerton, Anaheim, Fountain Valley, all of these areas that serve our drinking water, we have carbon activated beds. That's all we are doing right now. Environmental injustice is evidence because poor folks, they have no option. The best part of water pollution is you have options at least. Think about it, if there is an air pollution. Do you think that I'm going to Ambajari, their air is bad, I'm not going to breathe in there? There is no option essentially. So we are better off dealing with this problem here. Special thanks to my student Emma Hoffman Davis for her master's thesis on PFAS in San Francisco Bay Area, which is currently, right now is not in the public domain, but after 6 months it will be. There is a embargo, we haven't published it yet, so it is there. Christy Riley is currently my graduate student. She's doing thesis on mapping and creating heat maps about hazard indices throughout California. Alexis Ortiz and Everardo Chavez, my undergraduate students, summer undergraduate student, they work on this Orange County area only, and they have calculated the hazard indices for Orange County only. And the California Department of Justice for giving me $150,000 for 2 years to do the mapping study throughout California. There is a restriction on me about the data I can share. I cannot share everything, so this is the best I can come up with. With that said, I'll take your questions. This is the prime pen, just in case. It says no PFAS, so if you see the label, that's the one you should be using it. Okay? But with that said, thank you for this opportunity.
Thank you very much for such a lovely lecture. Today we have such a lovely and lively audience. I want all of you to have a big round of applause for today's lecture. Thank you so much. Now I request all the dignitaries to please occupy the dais.
Question and answers first.
Okay. Anyone want to ask any question? Since we are short of time, so we can take only 1 or 2 questions.
Very interesting. Thank you very much, Dr. Sudarshan, for a very interesting presentation. In fact, I don't have any question as such, but would like to add some information. Something you were mentioning about whether we have the quality standards, whether this is included or not. Unfortunately, we don't have any such parameter which is included in the drinking water quality standards. Normally we go by IS 10500, but normally CPHO, I hope you are aware about CPHO manual. There is a manual, Central Public Health Environmental Organization, brought out by them. And most of the state departments, they follow those CPHO quality standards, and that follows IS standards. There are hardly about 37 parameters or so. They don't include any of these things. But secondly, very limited studies have been carried out as far as emerging contaminants are concerned in India. Long back, almost 20 years back, for the first time, some studies were carried out by NIRI. Presence of pesticides in drinking water. Unfortunately, that data was not published in any of the Indian journals. It was published only in international journals for obvious reasons. Recently, and one of the limitations for this type of studies is the availability of sophisticated instruments. You know, this LCM, SMS or your other equipment in India, they are very expensive, and the water laboratories they can't afford those type of instruments to have in the testing laboratories. So that is one of the reasons why we are not going in for these parameters, estimation of these parameters, because requirement is very expensive. Thirdly, some studies were carried out by one of my research scholars for the presence of emerging contaminants and EDCs, endocrine disrupting compounds. And we did some study to find out the presence in the surface waters and drinking water. And as we have also mentioned, there is a presence of these compounds in drinking water also. That is obvious. It means that it cannot be removed in conventional treatment. Same thing is true here also. I feel that in course of time, in order to take care of these contaminants, your GSC, activated carbon, will become an integral part of the convention. That is the only solution. That's what I just wanted to add.
So I'll add another. I'll add something more, that we got scared after seeing this, everybody of us. But there is a good news that even though India has signed the Stockholm Convention long back in 2006, India has not recognized any PFAS up till now. So we should be happy, as he also told, that ये तो सब ठीक है, पर हमने तो recognize ही नहीं किया है. So there is a what we say, we are happy because we are ignorant.
Not to know our problems.
Blessing in disguise, I can.
If I do not know my problem, I'm living happy. Then somebody comes along, hey, you have that problem. Now the problem starts. Okay. In many studies that originated from India, they refer to the Bureau of Indian Standards only. If not, then about the Organization standard. And that was my question. Like, see, you have to understand that in 2023, the most developed country in the world, they came up with a drinking water standard. Okay. So I don't expect that overnight all of this country will start. Okay, let's do okay. Even though you have the standard, who is going to monitor? Where are the laboratories? Where is the medical? These are very difficult compounds to detect. Now there is a poor man's way of doing this thing. Okay. The poor man's way is ELISA, enzyme immunosorbent. It's a microtide plate meter. It's affordable, you know. And in American universities, that ELISA is a poor man's LCM. Okay. It does 96 tests for around $500. And anybody, like, if you are really familiar, wants to do a good research with your undergraduate students, get that ELISA plate meter. They are typically available in microbiology labs. Okay? It's not really a high-end instrument. But you can buy a kit for PFAS, specific PFAS. It's a semi-deterministic, but at least you get the feel. It's a good research. Having an undergraduate student running the ELISA test for PFAS, testing local water, I mean, it's a good start. You know, nothing else. But I think that's some of the hate. The whole purpose of this thing is to bring it to the attention that there are these compounds that need to be investigated. Okay, these are harmful compounds that are present in drinking water all over across the world. Now, most of the studies are restricted to Europe and North America, majority of them. I think there is a need that it should be looked into. Something like a kind of awareness presentation, right? The best I would say. At least before, I mean, some of you before coming here probably might not have heard about it. Now you are PFAS and curious. Oh, thank you. Any more questions?
Thank you so much, sir. And I invite all the dignitaries please of the panel. So this is time for felicitation of our today's guest. Now I request ex-President Engineer Sudarshan Kurwadkar sir to kindly felicitate our today's guest of Dr. Sudarshan Kurwadkar sir. I have a memento. Thank you so much, sir. Now, today we have come to the end of today's lecture program. So now I request Honorable Secretary Dr. Isha Khedkar ma'am to have a vote of thanks. Thank you, madam. It's my proud privilege to propose the vote of thanks on the occasion of late Dr. A.G. Bhole Endowment Lecture. At the outset, on the behalf of EVA and my personal behalf, I, Dr. Isha Khedkar, Secretary, would like to express my sincere gratitude towards esteemed eminent speaker Dr. Sudarshan Kurwadkar Sir, Professor, Civil Engineering Department, California State University, Fullerton, USA, for accepting our invitation and traveling all the way from USA despite of his busy schedule. Dr. Kurwadkar Sir beautifully provided us with the in-depth discussion on the topic Occurrence of PFAS substances in drinking water, mapping, monitoring, mitigation, offering valuable insights and knowledge. On the behalf of everyone present out here, I extend my deepest appreciation to Dr. Sudarshan Kurwadkar Sir for its enlightening presentation and sharing his valuable knowledge with all of us and especially with the students. My sincere thanks to our respected Chairman Sir, Dr. Royal Mukherjee, Dr. N.M. Bangre Sir, Vice Chairman of EVA, and Dr. B.A. Nasalkar Sir for their gracious presence and also inspiring us to host this program. I extend my sincere thanks to Vice Chairman Dr. Sanjay Roy Sir and P.K. Jain Sir, Dr. Rahul Gadegaonkar Sir, Treasurer, and all executive body members for their auspicious presence. I am also thankful to Snehal Abhinkar Madam for coordinating this event so efficiently. The contribution of 2 lakhs was given by A.G. Bhole Sir himself to start this endowment lecture. So we are able to arrange this lecture for you. I would like to extend my sincere thanks to Dr. Sanjay Roy Sir for reading the life sketch of Dr. A.G. Bhole Sir and Rahul Gadegaonkar Sir for reading the bio sketch of Sudarshan Kurwadkar Sir. My special thanks to the Subhash Bhujbal Sir, President EVA, Chief Engineer NJB Nagpur Region for raising this occasion. Thank you, sir. I would like to thank Megha for taking the responsibility of recording of this event. I am thankful to the supporting staff also. My sincere thanks to the press media for covering this event. Last but not the least, I extend my heartfelt thanks to EVA members and students of a various students chapter for their presence to make this event successful. Thank you, Manalo. As EVA Nagpur Center, we installed student chapter at Student Shri Gaikwad College of Engineering and Technology. So I request Dr. O.N. Mukherjee sir and dignitaries on the dais to hand over the student certificate. I request Madam to take that certificate. Professor Mohit Singh Katoch, please accompany the Madam.
57 members, sir.
Yes, sir.
Student coordinator, president, please join. All students are requested to come join the dais for the group photograph. After this, then it is followed by dinner. All students kindly join the dais for a group photo. Then all are welcome for a dinner. All students kindly join the dais for the group photo. All the faculty members along with the students kindly join.
Dash toast.
I request all the executive and all the members of IVA, please kindly join the dais for a group photo. All the members, all the dignitaries, kindly come and join for a group photo.
Hello, all these students, you all are requested to join for dinner outside on the right hand side of the hall. Please.
सब आने का मत करो। हाँ।